This video is going to be looking at electron configuration, and what you need to be able to do for GCSE is draw and do the electron configuration of only the first 20 elements. So that's what we're going to show you how to do today. The reason we go with 20 is because the 20th element is calcium, and after calcium in the periodic table you've got the transition elements, and the transition elements behave differently to all the others, or their electron configuration gets much more complicated, I should say. You'll also notice from the periodic table that I've got here that I've only used the atomic number. So this is the number of protons. You will have another number. That's the atomic mass, the number of protons and neutrons. But for the sake of this video, all you need to know is the smaller number. So in the case of lithium, that's 3 protons, which means I'm going to have 3 electrons. The reason being that I've got a positive charge of 3 plus coming from the nucleus, so I need enough electrons to balance that out. Each electron having a charge of -1, so I need 3 -1s to get -3 to balance out the 3 plus charge. I'm going to show you how I learned to do this. I'm going to use calcium as an example because it is number 20. So I'm going to show you how it fills up. So start off with, you'll write Ca in the middle, the symbol for calcium, or whatever element you are using. Now the first shell can only fit 2 electrons, so I will draw 2 crosses on that first shell. I cannot have more than 2. All right. Now, if I've already got 2 and I've got 20 electrons, I need 18 more. So I'm going to go on to the next shell. That's going to have 8 because that can only fit 8 on it. And the way you're going to fill it up is not to just evenly spread them around. I'm going to put 1 north, south, east and west, so to speak. Once I've done that, I'm going to then pair them up. It's kind of like seats on a bus. If there's an available seat, you'll always take it as opposed to sitting next to someone else. So now, on the next shell, I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons. Plus the 2 in the middle, 9, 10. I've got 10 electrons. But I can't fit any more else on the second shell. So I'm going to go to the third shell. And the third shell can also fit 8. So I'm going to draw my 8 on the third shell. Okay. Now, I'm then going to fill that up and I'm going to start pairing them up, just like those seats on the bus. So there you go. Now I've got another 8. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I need 20. So I'm just going to put 1 or 2 more on the outside shell. And that's what calcium should look like. And the way you will write this is 2.8.8.2. Because there are 2 on the first shell, 8 on the next shell, 8 on the next shell, and 2 on the last shell. And let's take another example. So if we take, I don't know, let's go with phosphorus. I'll use the actual pen here. So if we take phosphorus as an example, now going back to the periodic table, phosphorus is over here, number 15. That means it's got 15 electrons, unless it's an ion, in which case it will have a different number. But as far as atoms are concerned, it has got 15. That means we can fill it up with, like we did with calcium, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this, and then going to the third shell, you would just put 1, 2, 3, 4, 5, because 10 on the 2 first shells and then 5 on the outside shell. So in that case, the electron configuration would be 2, 8, 5. However, I'm going to show you another way of doing this, and it's slightly easier. If you look at the first row in the periodic table, the first period in the periodic table, I should say, there are only 2 elements, hydrogen and helium, which means that that first shell can only fit 2 electrons. So it's going to be in row 3, so I'm only going to use, or period 3, so I'm only going to use the first 3 shells. Okay, so this outside shell here is actually irrelevant to this diagram. We'll go back. The next shell has got 1, 2, 3, 4, 5, 5, 6, 7, 8. Funnily enough, that period has got 8 elements in. So I'm going to fill up and put an electron for each elements in that period on that row. And I fill up that shell. Then I go on to the next shell and I go 1, 2, 3, 4, 5, and I get to phosphorus. So therefore, on the first period, second period, third period, and therefore the third shell, I'm going to have 5 electrons. And so on the outside of that, for phosphorus, I'm going to do 1, 2, 3, 4,